Mathematics may not teach us how to add or subtract love, nor does it teach us how to subtract hate, but it can give us a good reason to believe and hope that there is no problem without a solution. Good day, my wonderful people. It's good to have you here again. Today, we conclude linear programming by looking at the type of questions you can possibly get in an exam. Pay attention and stay tuned.
This time, we are going to look at a combined example. By a combined example, I just mean we are going to look at an example that includes both situations when we have one variable involved and when we have two variables involved. Now, an example here says, write R in the region satisfying the inequalities y is greater than or equal to 0, y is strictly less than x, and x plus y is less than or equal to 5. So now some of you see this, you already think it's ugly. It's not. I was never taught about that thing. But what you are going to do is you are going to use the application, the methodology that you were taught, and apply it in any type of equation that is given to you. Remember, your teacher will not give you all the possible questions regarding linear programming. What they are going to give you is some examples and then the methodology that you are going to use to solve this type of question. So you want to keep that methodology and those formulas and those steps in mind and those conditions surrounding the topic in mind, and then you apply it at any. I can challenge you with however ugly, you know already that this is how I solve situations in linear programming. Now, what I want to do first is I want to know that I'm not going to go to the grid yet, because here we don't have our, in some question papers you might find that they already drew part of your graph, or sometimes they just give you a graph paper you need to start from scratch. So you don't want to really go to the x and y axis because you don't know your limits. I'm going to start inequality 1. I have y is greater than or equal to 0. So what do I have here? I just have one line, one variable involved. So I already know this line is going to be a solid line, and it's gonna go through the y equal to 0 point, which means it's going to be the x-axis. So I already have that in mind. I go to the next one. The next one, they said y is strictly less than x. So I want to know, where will this graph cut the x-axis or the y-axis? I make this an equation. Remember, we have y is equal to x. That's what they are saying when we make it an equation. So it means actually when I have, that's just at the back of my mind, I know if I'm saying, I'm trying to make sense out of the equation here. Because some of you see y equal to x, you think it's Chinese. It's just saying when y is 1, x is also 1. So that's what it's saying. It means when y is 1, x is 1. When just some points, some coordinates that I just giving. When x is 3, y is 3. When x is -3, y is -3. They are telling you it's equal. That's what the equation is saying. So I keep that in mind. And then the third one, I want to include all these things. So I wanted to make sure I have an idea of each of them. So I have x plus y is less than or equal to 5. And I know this will be x plus y is equal to 5. Then I know I'm going to say, okay, to get the x-intercept, because I need the x-intercept for this to draw this graph, I'm going to say y is going to be 0. I'm going to set y to be 0. So it means x plus 0 is equal to 5. So that tells you already that the x-intercept is at 5. So x equal to 5 is your x-intercept. Then if you let x to be 0 for the y-intercept, you let x to be 0, then you're going to have 0 plus y is equal to 5. So you also, it's like similar to the previous example, we have y is 5. So it means your graph is cutting the y-axis at 5 and the x-axis at 5 in this case. So it means I want to include 0, I can include any number from here, negative side, positive side, and I want to include 5. Why am I doing this rough working here? I just want to have an idea of what my limits on my axis will be, my coordinates, my numbers on both axes. What should I include? Where should I end? Then I come to drawing my graph. Remember, all these inequalities, we are representing them, but I would advise you, every time you draw one, find the unwanted region, shade it already, so that you don't draw lines, and then you come and figure out the unwanted. So I have my y-axis and my x-axis. Y is equal to 0. Where is y equal to 0? It's this line. So I write it, y is equal to 0. Why am I writing it, labeling it? To just know that I have drawn that line, that equation already. So then I see, go back to my inequality. I can now try not to find all the values. Now I have an understanding from the previous example, so I can make sense out of just looking at it. They are saying y is greater than or equal to 0. So I'm at y equal to 0. Greater than or equal to is either, if it's equal, is on this line. If it's greater, is above, because I know it increases from bottom going up. So it means my unwanted will then be below. Why below? Because this is what makes the inequality to be false or be not true. So that's my unwanted region for that inequality. So it means I have shaded that. I'm done with that one. I go to the next one. They said y is less than x. So you come here, you said when we make it an equation, y is equal to x, it means when y is 1, x is 1. So you want to choose maybe a point at the end here at negative x equal to negative 3, y is also equal to negative 3. When y is 0, x is 0. When y is 5, x is also 5. Just choose random points just to see how your graph is going. Because it doesn't help you know this, but if it's going like that, you need to make sure. But you are already supposed to be able to look at that and see when x is equal to y, it means same value. So then I have to now draw my graph. Take my straight edge, my ruler, and then put it down to connect these points. Make sure I have a straight line. So I'm going to draw a broken line. Remember, these broken and solid straight lines still plays a very important role here. You don't want to make this a solid line and have a wrong answer. Because these here, an equal sign is not involved. Here, an equal sign must involve. That's why we had a solid straight line. So now we have our broken line. So now you want to know, remember I said we have a trick that we just look at the symbol. So if it says it's less than, like this one is saying less than, so less than, we want to know that it's below the line. So it's below, less than will be below. Above will be here. So it means if less than is there, remember, because below the line is always, if it was like this, we would say above, below. Now that it's like this is top. So bottom is there under. So this part is going to be my unwanted region. Because this part, this symbol is saying less than, and I said below is the less than. Just to confirm that we are indeed right, choose a point this side. Let's say we want to choose a point here. If we choose a point there, we could choose a point 3, 1. We come and put it here. When x, okay, choose a point here. So we're saying 3, 1. So we will say y is 1 and it's less than 3. Is that true? Yes. But if you come to this side, you take a number here. Let's say we take this point, negative 2, 3. Then you see if we substitute in the inequality y is less than x, y is 3. Is 3 less than negative 2? No. That's why it's our unwanted. So that means our trick is actually working. What did we say? We look at our line. Above the line is greater, below the line is less. So we are now done. We don't want these lines to disturb us. So we want to take our eraser and make sure it's neat. So we have shaded those. Now we are done with this as well. Then we come to this one. This one we got that our x-intercept is at 5. So our x-intercept is here, just making it visible. And then we have our y-intercept there. Then we know it's a solid line because the equal sign is involved. So we are going to draw a straight line going there. You can go beyond that, just extend it to make it straight. Then we see that, okay, we have our line now. We want to shade the region. We look at our symbol again. Less than is below, more than is there. So because it's less than, our wanted is below. So our unwanted will be here. So that's what you will have in the end. You can try this example on a clean graph paper just to have to make sure you understand the example. So now that's what we are supposed to have. We have shaded, that's our unwanted region, that's our unwanted region, that's our unwanted region. Don't forget to take note of your equation. X plus y is equal to 5, and then your equation, label them. It will be neater there in your book. Then You remember they said write R in the region satisfying. So this part is satisfying both inequalities. So you write R there. So mathematics is nothing like, it's not magic, it's understanding. So get rid of the myth that it's difficult and try understanding it. Because now that it's compulsory for all the grades, you don't have a choice. So we are going to look at the practical part of linear programming. So make sure you pay attention so that you can understand how you solve linear programming like practically. Now, before we move on to an example, we are going to look at a few steps that we are going to apply. But before the steps, we are going to mention a few or look at a few inequalities that we are going to make use of as we solve these linear inequality practice. Let me tell you something like less than 5. Let's say less than 5. You are going to use the symbol less than 5. If they say more than 5, you are going to use the symbol more than 5. But they can make it more interesting and they would use words. If they say at most 5, or maybe they could say a maximum of 5. Not more than 5. Then in this case, you would use the symbol less than or equal to 5. If they say at most 5, that means the highest value it can possibly be is 5. Otherwise, it has to be less. A maximum of 5 still means the same thing. Not more than 5 still means it can be 5, but not anything more. It has to be less. So that's why we are going to use less than or equal to 5. Now, other times they could say at least 5. A minimum of 5. Or maybe they could say less than 5. In each one of these 3 cases, you would use the symbol greater than or equal to 5. It just means if something has to be at least 5, then I want to at least have a 5, otherwise I can have more. An example, your teacher could say, for you to pass the test out of 30, you should at least get a 15. That means you can get a 30 out. To look at 4 steps that we apply when we solve linear programming practical questions. So we have 4 steps. Number 1, make sure you identify all your inequalities for every condition. You now draw your straight lines. And remember, in linear programming, when we draw our straight lines, we need to make sure that as we draw one line, we shade the unwanted region. We draw the other one, we shade the unwanted region, so that we don't get confused. So we draw our straight lines. As we draw our straight lines, we already go to number 3 where we are shade the unwanted region. In the final step, we find the maximum and minimum, or maybe depends on what they ask you, but we will need to find the maximum and or minimum point in the required region. We are going to look at an example. We will make use of those steps, make use of these inequalities, so you need to have them somewhere as we solve and apply them in the next in the example.
The question that we are going to make use of as an example is taken, or I took it from paper 1 of higher level 2015, which was question 16. It reads, in a school gardening project, teachers and students carry soil to a vegetable plot. A teacher can carry 24 kg of soil and a student can carry 20 kg of soil. Each person makes one trip. Altogether, at least 240 kg of soil must be carried. There are X teachers and Y students. In A, they asked, show that this information leads to the inequality 6x plus 5y is greater than or equal to 60. So to show this information, underline the most important things there. You see that the teacher, I must use X, and the students, I must use Y, and then that at least together the total should give you 240 kg. So you show that. It simplifies to 6x plus 5y greater than or equal to 60. In B, they are asking, there must not be more than 13 people carrying soil. They told you that. So they want you to write down another inequality for this information. So, and then in C, there must be at least 4 teachers and at least 3 students carrying soil. Write down another 2 inequalities. Okay. And then in D, they want you on the grid that you see there to draw all 4 inequalities on a graph paper on that graph pad and use a scale or using a scale of 1 centimeter to represent 1 unit on both axes. Shade the unwanted region. For that, you get 5 marks. So you have to make sure you get these marks. E, which is the last question, it said from your graph, find. First, you find the least number of people required, and secondly, you find the greatest amount of soil which can be carried. So we are going to look at, please make sure you always look at your marks so that you can see how much work you should actually put in or effort you should actually put in, and then we see now. Okay, so we are going to read each question again as we solve it. Stay tuned.
Now take note of the fact that they are saying for teachers, I must use X, and for students, I must use Y. And remember, each teacher can carry 24 kg and each student can carry 20 kg. Okay, so I need to take note of that information, and then I look at what they're asking me now. They said, show that this information leads to the inequality 6x plus 5y greater than or equal to 60. So I need to show that. So in A, they want me to show that the information they gave me in the instructions simplifies to 6x plus 5y greater than or equal to 60. So remember, we are showing that we are simplifying to that. So we go back to our question and we know they are saying this, each teacher can carry 24 kg. So it means I'll take 24 kg times x, depending on how many teachers I have. So x for number of teachers plus 20 kg times y, which is the number of kgs times the number of students, is going to be greater than or equal to 240. Why am I using greater than or equal to? Because they told you at least 240. It can be greater, but it should at least be equal to 240. That means it's greater than or equal to. Plus, I already saw my symbol from what they are saying. I should show that it simplifies to. So I can already just take it from there. But I should know where it came from, however. Then I need to simplify this. So I'm going to divide this by a common factor. I could use 2 because I see they are all even numbers, but I know that the highest common factor here is 4. So I will divide by 4. Remember I said you can still divide by 2. Just make sure when you divide by 2, you will still have numbers that are divisible by 2. X divided by 4 is going to give us 6x. 20y divided by 4 is going to give us 5y. And 240 divided by 4 is going to give us 60. Then we have simplified. We showed that we had this, we divided each one by 4 and we got that. So we've answered A. B, they are saying there must not be more than 13 people carrying soil. So they're saying, in B they are saying there must not be more than 13 people carrying soil. Not more than. So it means in B, I'm going to say the number of teachers plus the number of learners should not be, so it should be less than or equal to 13. It can be 13, but it shouldn't be more. So that's my answer to B. Because remember, in B, they ask you to write down another inequality for this information, so you are writing that down. So they're saying there must not be more than 13 people carrying the soil. So you need to write that inequality down. And in C, they are saying there must be at least 4 teachers and at least 3 students carrying soil. Write down another 2 inequalities. So they said at least. So for teachers, they should at least, that means they can be more, but they should at least be 4 teachers. So there should at least be 4 teachers, meaning more than or equal to 4 for the teachers, and for the learners, more than or equal to 3 students. So that is my inequality for the students. And then in D, they said on the grid below, which is our grid here, we are going to draw all 4 inequalities on a graph paper using the scale, very important, the scale 1 centimeter to represent 1 unit on both axes. Shade the unwanted region. So we want to answer D, and we are going to answer it on this graph paper. So we need to make sure we remember we wrote down our inequalities. That was our first step. Now we are going to draw our straight lines. As we draw our straight lines, we also shade the unwanted region, and then we'll see what E asks us. Probably it will ask us to find we'll need to find the maximum and minimum. About our inequalities, we had 6x plus 5y is greater than or equal to 60. We also had x plus y is less than or equal to 13. We had x is greater than or equal to 4, and y, remember 1 centimeter to represent 1 unit. So we must keep that at the back of our minds. But we want now we need to include here. So we will need to draw these straight lines. So here we need to take note of our x-intercept. Our x-intercept, remember we get it by letting y to be 0. So if we remember, we also change our inequalities to equations. So if we let y to be 0, we have 6x is equal to 60. Because if we put 0 there, then it's 5 times 0, then it's gone. So we just have 6x equal to 60. Both sides by 6, both sides by 6, we have that x is equal to 10. So our x-intercept for that equation is at x equal to 10. And our y-intercept, if we get y-intercept, we let x to be 0, so it will be 6 times 0. Then we have 5. Y is equal to 60. If we divide both sides by 5, we have y is equal to 12. So our y-intercept here is 12. So we get our x-intercept and our y-intercept there. Then we come to this one. If we let y to be 0, the x-intercept will be 13, because it will just be x plus 0 equal to 13. So it's just 13. And for this one, the y-intercept will also be 13, because I see that if I let x to be 0, it will just be y is equal to 13. This one is already just going to be x equal to 4, and this one is going to be y equal to 3. So we have our straight lines, or our at least guidance to draw our straight lines. 1 centimeter is 5 little blocks. So after 1 centimeter, they said I should have 1. Another 1 centimeter, 2, 3, 13. I can at least go until 14, or I can even go until 15. Anyway, as long as 13 is there. I do the same here. 3, remember, 1 centimeter, 1 unit. So 5 little blocks, 1 unit, because 5 little blocks is 1 centimeter. Remember, I've already taken note of my lines here. So I want to come and put them down on the graph. I want to draw this one first. So I have my x-intercept at 10, my y-intercept at 12. So y-intercept is at 12 and x-intercept is at 10. So I've done that. So I'm going to take my straight edge, connect the 2 points to draw a straight line. Remember, the next step after we have our equations, we draw the straight lines. So this is the line 6x plus 5y equal to 60. So I can shade my unwanted region. We are going to use the shorter method that we looked at in other examples. So if we are saying the symbol was greater than or equal to, greater than is that side. So that's our wanted region. So our unwanted region is this side. The next straight line cuts the x-axis at 13, because the x-intercept is 13. The y-intercept is at 13. So we connect those 2 points again to draw a straight line. Remember our next step, drawing our straight lines. Then this is what we have. So if we draw our straight line, that's the line x plus y is equal to 13. So we have our line there, and then we go back. Our inequality, this inequality was x plus y is less than or equal to 13. So it means less than or equal to 13 is below that line. So our unwanted region will be here. If the wanted is below, our unwanted is above. Remember. Okay. Then we have, that's our unwanted region for that line. Then we have the next line. The next line is at x equal to 4. Where is x equal to 4? Here. So we draw our straight line. Remember, all these lines are solid straight lines because we see that they are all having, or the equal sign is involved in all the equations. So this is what we have. This is the line x equal to 4. So we see that the inequality was x is greater than or equal to 4. So x greater than or equal to 4 is that side. So our unwanted region would be this side from the line going to the left, because we see that this is the opposite of what we want. So that will be our unwanted region. So that will be our unwanted region there for this one, for that line. And then we go to the next one, which is the line y equal to 3. And the line y equal to 3 is here. So we take our straight edge again and draw our straight line going through the line y is equal to. So that's the line y is equal to 3. So we see that the inequality was y is greater than or equal to 3. So y is equal to 3 here is, y is equal to 3 is here, y is greater than 3 is above. So our unwanted region will then be below. Then we are done answering our question D. So that's our solution to D. They're asking you to find the least number of people required. Least meaning the smallest possible value. So you will go to the required region. Remember, your required region is the one that is not shaded, which is here. So you choose points that are going to be at least at the edge there, so that you know this is going to be your smallest point. So the first one will be here. You don't want to go to points that are going to give you decimal, because they are asking for a least number of people. If you use decimals, you're not going to get a whole number, and you're looking at number of people, so you want to make sure that you get an answer that makes sense. So you choose a point, let's say that point there. Then we go to this point here. We can also choose here as well. We see this as well. If you choose those points, if you choose these points, you're just choosing points that are kind of close to the end of the line, because that's your least point, your smallest possible points in your required region. So this coordinate of this point is going to be 5, 6. So I have 5, 6. And the other one is, the next one is going to be 6, 5. So that one is 6, 5. The next one is going to be 7, 4. So I have 7, 4. And then the last one is 8, 3. And then I have 8, 3. If you look at, they're asking for the least number of people. Remember, this is the first number is always xy, 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 xy. So if you add your teachers to the learners, what do you get here? You will get 11 here, you will get 11 there, you will get 11 there, you will get 11 there. So what does that tell you? It tells you that actually the least number of people I can have is 11 people. So that's your answer to the first question in E. The second one, they're asking you for the greatest amount of soil which can be carried. So you want to go to the greatest, meaning you want to go to the highest possible point in the required region here, and then maybe here as well, which will be here. To choose points there, so you can choose the one there and the one there, because you might need more x, y values and less x, then you might get a bigger answer, or maybe more x and few y's, and it still gives you a bigger answer. So you want to see which one is which. So if you look at this coordinate, it will be 4, 9. You are looking at the greatest point in the required region now. And then the next one will be 10, 3. So what are these? So this is, remember, it's your x and your y, and your x and your y. So you want to see now, remember, the greatest amount of soil. So if we now say X is, and remember, the teacher can carry 24 kg, the learner carries 20 kg. So I'm keeping that in mind. So for this point, I'm going to say 24 kg times 4 teachers plus 20 kg times 9 learners. What does that give me? It gives me 96 plus 180 plus 96 gives you 276. Then I go to the other one. What if it's now 10? I'm going to say 10 times 24 plus 3 times 20. That is going to be 240 plus 60. That is going to be 300. So I can already see here I get the highest because that's low. So that means my answer is the greatest amount of soil that can be carried is going to be 300 kg. So I'm going to give this as my answer to the second part of question E.
Thank you so much for watching. Don't forget to like, subscribe, share, and leave a comment. You may as well recommend the topics you want us to look at next. See you in the next video.